Continuing on with the Math 13-14 Final Exam Review, number 12 asks you to find the vertex of this quadratic function, y equals x plus 4 quantity squared minus 4. This is written in vertex form, and recall vertex form is y equals a times x minus h quantity squared plus k, and that tells you that the vertex is hk. So my vertex is going to be negative 4, comma, negative 4. I know that this parabola opens up. And why do I know that? Because my a, which is 1 out front, my a is positive. If a is positive, it opens up. If a had been negative, it would have opened down. So my vertex is here at negative 4, and I know that I'm going to open up. My domain, the domain for all parabolas is negative infinity to infinity. The range, when I come in here on my y-axis, the range will start here at negative 4. Sorry about that. The range will start here at negative 4, and it will go on up to infinity. So the range starts at negative 4 with a bracket and goes up to infinity. Number 13, find the domain of the function y equals the square root of 4x minus 5. When you have a square root, you know that anything underneath has to be greater than or equal to 0. So I'm going to solve for that. 4x minus 5 greater than or equal to 0. To get x by itself on the left, I need to add 5 to both sides. So I have 4x is greater than or equal to 5. Dividing both sides by 4, I get x greater than or equal to 5/4. So my domain will start at 5/4 with a bracket and go up to infinity. If you recognize the parent function y equals the square root of x, but it's been shifted to the right here at 5/4, so a quick sketch of this graph is going to look like this. My range, what y values coming in here, it starts here at y equals 0 and goes up to infinity. So my range is bracket 0, comma, infinity, parenthesis. Number 14, it wants the domain and the range of the function y equals negative 7 divided by x minus 6. Since I have technology in my hand, I went over and graphed that function on my graphing calculator just to get a quick sketch of it in my head. Now I'm going to go back over to my skill set and recognize that the denominator of a rational function cannot equal 0. So when does x minus 6 equal 0? Adding 6 to both sides, I see that that happens when x equals 6. So I know that there is a vertical asymptote at x equals 6. And if you'll look here at my hand-sketched graph, I did a dotted vertical line at x equals 6. That's a vertical asymptote. You can see it here in the graph on the calculator as well. Okay, so my domain is going to be all real numbers except for 6. And how do I say that in interval notation? Parenthesis negative infinity, comma, 6, parenthesis, union, parenthesis 6, comma, infinity. So this right here says to eliminate the number 6. Okay, because I know about rational functions, I know that the degree of the numerator is less than the degree of the denominator in this one. So I know that I have a horizontal asymptote at y equals 0. Again, the degree of the numerator is 0. The degree of the denominator is 1. The degree of the numerator is smaller than the degree of the denominator, so I know I have a horizontal asymptote at y equals 0. And you can see that I sketched that here on my graph. On the graph on the calculator, it's right here. Okay, that helps me find the range. The range, I'm going to have to eliminate the value y equals 0. So I say negative infinity to 0, stop at 0 with a parenthesis, union, pick everything from 0 to the right. Pick everything up that's bigger than 0, and that's what this says. Again, I needed to kick out the value y equals 0, and that's how you do it in interval notation. For number 15, I'm given the function f of x equals 2x squared plus 3x plus 5, and I'm asked to evaluate f of negative 3. So everywhere I see an x, I'm going to type in negative 3. 2 times negative 3 squared plus 3 times negative 3 plus 5. When I evaluate that, I get 2 times 9, which is 18, minus 9 plus 5. So my answer is going to be 14. For number 16, I'm given the function f of x equals 3x squared minus 5x plus 4, and I'm asked to evaluate f of negative x. Everywhere I see an x in my original function, I'm now going to type in negative x. So I have 3 times negative x quantity squared minus 5 times negative x plus 4. Negative x quantity squared, I have negative x times negative x, which is a positive x squared. So I have 3x squared plus 5x plus 4. For number 17, I'm given this graph, and I'm asked to find f of negative 3. Negative 3 is an x value. So on my graph, I go look at the x-axis where is negative 3 and find my point. It's asking me to give the y value. So the pink dot on my graph is at the point negative 3, 0. So over here, f of negative 3 is equal to 0. Part B says to find x when f of x equals negative 2. They want you to find the x value when the y value is negative 2. When is y negative 2? I see 2 times that occurs, and that's at the x value negative 2 and at the x value 3. Number 18 asks you to find the average rate of change illustrated in this graph. And I want you to remember that the average rate of change is found by doing f of b minus f of a over b minus a. And that represents the average rate of change of the function y equals f of x from x equals a to x equals b. Okay, our a value is going to be 0. So our point here is 0, 35. And our x equals b value is going to be here at 60. And this point is 60, 50. So I want to find the average rate of change between these 2 points. To do that, I'm going to do f of 60 minus f of 0 over 60 minus 0. F of b, which will be 50, minus f of a, so f of 0, which is going to be 35, over 60 minus 0. That comes out to be 0.25. Now in this problem, my y values are going to be measured in dollars, and my x values are measured in minutes. My average rate of change is a change of y with respect to x. So this is going to be 25 cents per minute. Dollars per minute is my unit. Number 19 is another rate of change. A deep sea diving bell is being lowered at a constant rate. After 10 minutes, the bell is at a depth of 600 feet. After 50 minutes, the bell is at a depth of 1900 feet. What is the average rate of change of depth? And round to 1 decimal place. So I'm going to find two ordered pairs in this information. My x value is going to represent time, and my y value is going to represent depth. It says after 10 minutes, I'm at a depth of 600 feet. So I have one point being 10, 600. It also tells me that after 50 minutes, I'm at a depth of 1900 feet. So I have a second ordered pair, 50, 1900. So my average rate of change, remember, is the change in y's over the change in x's. So the change in y's, I have 1900 minus 600. My change in x's, I'm going to have 50 minus 10. So I come up with 1300 divided by 40, which is 32.5. Now what's my unit? Change in y over change in x measured feet per minute. So my average rate of change is 32.5 feet per minute. Number 20, I'm given a piecewise defined function. Here's how it's defined. Notice I have 3 different intervals for my x values. It is defined a certain way for all x's that are less than 1, and that's defined by the green function here. I have a rule that says how it's defined for all values between 6 and 10 inclusive, and that's given by the red. And I also have a rule that defines it for x's bigger than 10, so over here. And that's the orange. Okay, I want to find f of 6 right here. F of 6. Where is 6 on my x axis? And I notice that it's right here. And it was colored red. So it must obey the red rule. Everywhere I see an x, I'm going to type in a 6. 6 times 6 is 36. Had this asked for f of 0, where is 0? It's here on the number line. So I would go to my green rule and say 2 times 0 plus 1, which is 0 plus 1, which is 1. What if I had asked you for, let me scoot that over. What if I had asked for f of, say, 20? Where is 20 on the number line? Well, it's way up here. It would be an orange. So everywhere I see an x on my orange rule, I would plug in 20. 6 minus 6 times 20. 6 minus 120 is negative 114. For number 21, you're given this graph, and you're asked to find the y-intercept, the x-intercept, and the slope. Okay, the y-intercept, I'm going to make this a little bit bigger. The y-intercept is where it crosses the y-axis, and it's right here. So it is at the point 0, 2. The x-intercept is where it crosses the x-axis, which is right here, and that is the point 4, 0. To find the slope, to go from the orange point to the pink point, I need to go down 2, so -2, and then I need to go right 4, so +4. My slope would be -1/2. And just a quick review, a decreasing line has a negative slope, an increasing line has a positive slope, a horizontal line has a slope equal to 0, and a vertical line has an undefined slope.